Hummus. Hummus? Hummus is delicious. I have an issue with eating too much hummus. You know what hummus is made of?
Cheese.
What?
Like those
Chickpeas.
white chickpea thing.
What did you say?
Like,
I meant
For a second,
circle beans.
They're not beans.
Okay.
Okay. Wait, are they the
Dang it, I did the 6.4
I wanted to see what David would say. He just said okay.
Did
Just
you look
letting
into
it go.
see if you
Yeah.
labeled it wrong?
Yeah, I knew I was wrong.
I don't
Okay,
know
I
what
knew
you-
they were
okay,
called
wait,
chickpeas, but then I forgot and I just went beans.
I learned.
Would you like to check my plan book, Leon? Because we can also do that. I don't know why I started recording.
No,
Oh,
you did
Sammy's back.
6.1, so we did just
Yeah, I know.
6.4.
We weren't starting and we were doing it.
We are now. We're waiting for you.
So I decided to go get this. And then
Are you guys good now?
I don't know when my 6.1 is.
I learned little little tricks.
Did you do?
Probably
That was back when I was writing homework in this plan book. Because I don't have it. Did you guys get your Phoenix plan books yet?
Yeah.
Who gave them out to you?
Miss Smith.
Well, I'm going to go see if she has any extras.
Oh my goodness.
Liang, 611 came from February 9th. Not December. Sorry, I'm thinking about next month instead of last month. December 9th was 611. I mean, it was a while ago, but I just collected homeworks and batches, like in chapters. All right, are we ready to dive in? Because we don't have much lesson, but we're going to talk about where this chapter is going and kind of the ways we have to think about things and conjectures. What is a conjecture?
No clue.
Like a.
Isn't it like
Something we don't know.
something that we think is right, but we can't necessarily prove? What's impossible to prove?
You were really close, and then you went further away.
Put all this together.
What's a theorem?
I think it's
Like a statement that's
fact that has a lot of everything.
A fact of a lot of everything? Is that what you just said?
No, I said like.
That's what I think I heard, but I think three people were talking at the same time. So, you said something that's been proven.
Yeah.
You said a fact. And then
That's not been proven.
a theorem. Ooh, something that hasn't been proven wrong. So it has not been disproven.
But it could be.
A theorem is what a conjecture grows up to be.
Conjecture is a theory that's not been proven.
A conjecture is like Baby Yoda.
Okay.
So a conjecture is something we think is true that we then need to try and prove. A theorem is something that we believe to be true, we have proven it, and no one else has disproven it. If somebody disproves our theorem, it's no longer a theorem, it's just broken. It's not
What
true.
if they disprove it wrong?
What
If you disprove it wrong,
Like when they're disproving it, they did something
then they didn't disprove it. They just did math wrong, and you laugh at them.
Someone
What
disproved
if
gravity.
they
They try to disprove it, but they
Someone
end up
who
proving
disproved.
it.
I want someone to disprove gravity just for fun of it.
So, like, the theorem of gravity is because it hasn't been disproven, right? We don't really say, like, the fact of gravity because we know, like, that we don't know everything, right? Like,
So would fact be like 1 plus 1 or would it be the theorem of 1 plus 1?
that'd be like the theorem of sums, right? Like that two numbers when put together act like this and become this. So we can say there are facts. Like I was born on April 30th, right? Like there are facts. But when we talk about math and science and things like that, we're saying this is our theorem because it's what we know and believe and hold true right now.
What if it's stuff you taught this whole generation this and then this person was like, that's wrong, and then the entire
Yes,
generation.
it would. But which would suck more? Realizing we were wrong or never knowing we were wrong? I'd rather somebody prove me wrong than me to be wrong forever. So Carla knows, gotta love Carla, that a parallelogram has two pairs of parallel sides. Oh, good, she can define parallelogram. She has studied special properties of isosceles triangles. What's isosceles mean? Two sides the same. And right triangles. she wonders if parallelograms have any special properties. So she remembers that it is possible to create a quadrilateral that looks like a parallelogram by rotating a triangle about the midpoint of one of its sides. Who remembers that tessellation activity that we did that ended up looking like a bunch of different tiles of parallelograms that were broken up into triangles? Yeah. Think back, there was on a half sheet,
Yeah.
and we extended the lines, and we kept extending the lines, and
Didn't we do? Was it the one where we colored like all the sides and then
Yeah.
angles?
we colored the angles to show which angle is equal to which angle. Remember that now? We were using colored pencils. So this is what Carla's remembering back to. And while technically this theorem would work for any of the sides, right? She's saying, why did you worked this morning and now you're not going to work? And my doctor wonders why I have high blood pressure. So if we use the point on the top, quote unquote, top side here, we're going to say that's the midpoint, but then I'm going to draw my triangle.
So then you can rotate it.
So yeah, then I can rotate it.
Oh, would you look at that?
Would you look at that? Now, if we just rotated it, can we say this is parallel to this?
Yes.
Yeah.
Okay.
We can also say that those are parallel. Yes.
We can say this.
Yeah. And
We can say that that side is.
we know the angles.
Ooh, we know the angles because we got the angles from our picture. So that has two arcs.
That has
Well, yeah. Also, because we know parallel.
This
They're the
has
same size.
one tick, two ticks.
Okay, so now.
Oh, and since we know the angles, that's how we can prove the parallel, right? Because alternate interior. So although we know it, quote unquote, we could prove it if we did alternate interior. We prove this is parallel to this, or this is parallel to this, because they're alternate interior for both of them.
So it's a parallelogram.
A parallelogram.
Two pairs of parallel sides.
Why do you stand on those?
It's just a little bit softer. They have like actual foam mats that you're supposed to like. It's like big, but I'm cheap and I have no money to buy that. And I had these sitting around my house. I can't quite remember why, but
Okay.
I had like a memory foam mattress topper thing I almost brought, but then I really figured you guys would judge me. So, if we're looking for what else we can figure out, look at question C here, and you have this on your paper. Okay, so go ahead and draw a line to kind of make your parallelogram on your paper look like Carla's parallelogram, the copy of the triangles. And I don't have my camera to work along with you. I told Miss Akona I didn't need it because I didn't want her to feel bad. But I was going to show you, like I was going to do this with you guys. Go ahead and label some angles inside of that, just like we have up on the screen.
So make it almost identical.
Yeah, essentially make it match. You could do like a double arc instead of or you could do like a single arc, a double arc, triple arc if you want. Or you could color code it if you felt like it. Oh, new chapter. I get to switch it up. Chapters in my binder over here. Wow. Volume 1. Only volume 1.
You just like.
Why are you doing that?
Oh wait, we were supposed to do. Oh well, we did that. We did this.
No, wait, did you draw your line a different direction?
No. Because if you draw the line in a different direction, then it'd be different. Right? Because you'd have to do like different angles and different.
No, wait, would it still be true that those would be congruent triangles?
Yeah.
same triangle.
So what if you draw the other diagonal? Connect your other two corners. Like, so draw both diagonals, essentially. Is what I'm saying.
An X.
Yeah, you'll have an X in the middle.
You wouldn't. This
I-
This is confusing.
I don't know if this would be
Would that be a right angle?
which one.
The angle created by the diagonals.
Which angle?
No?
I can't tell which is now.
Can't tell which angle you're talking about.
The middle, the X, the thing that you're saying, oh, we did an X.
X is 4 angles.
Yeah. If one of them's right, they'd all be right. So what I'm asking you is there any special relationship in there?
We know that it's vertical angles, but they're not equal because
Oh,
of the
they're all-
triangle angle sum theorem. There's different, so if we have of like the one corner, so like the half of one of it plus the double arc,
Okay.
minus like 180 minus like one section of the single tick plus a double arc. That might not be the same as the other section of the single tick plus the two ticks.
Yeah, okay. And we do have,
Wouldn't it like have to be a square for like all those angles to be 90?
we do have supplementary there, right? We have 180 degrees.
Yeah.
So we at least have supplementary. We at least have vertical. Probably not the right angle we're saying, but then Sammy inserted the, well, what if it was a square? 'Cause is a square a parallelogram? Yeah, right? I mean, square is just a better name for it, but it is.
That means that all the sides would be equal to each other.
So
What
not
shape has sides that are equal to each other?
If it was a square, it would be right.
I thought
Rectangles don't have sides that are all
Yeah.
equal to
They're
each
all,
other.
all equal?
Yeah, what
Yeah.
kind of shape has
Oh,
sides
I
all
thought you
equal to
just
each other?
said some equal to each
A square, but what other shapes have all sides equal?
Equilateral triangle.
What quadrilaterals have all four sides equal?
Couldn't you do like hexagons?
That's not a quadrilateral.
No, I know it's not quadrilateral.
I'm trying to remind us of the name of this special type of shape. A rhombus. I didn't hear you speak up. I genuinely did not. Sorry, my ears are not 100%. But yeah, a rhombus, right? So hold on. So we're saying if the parallelogram became a rhombus, which would make all sides equal, and oh wait, would that just fix it? What if all of our sides were equal, but it was still a parallelogram? It was still tilted. I'm trying to think, would that be 90-degree angles then? The base would be same as the. We'd have like an isosceles triangle then, right? If our parallelogram was a rhombus, is a right, like it can be both at the same time, right? Parallelogram equal sides. And then we'd have, so then like the base would be equal length to this side, right? Okay. Yeah, we're going to come back to that. I just want to make you guys think about it. So, this question here, some of these are quick, like kind of buzz through questions. Does this diagonal always create congruent triangles? Why or why not? Any hands, so we can hopefully pick one of us to answer. Leanne, since I was so rude and missed your comment last time.
It was because like they have the same angles.
What do you mean?
Because like alternate interiors, so the angles are the same. And then they share the side length, so it'd be sided.
So if we need help visualizing this,
So they have the same, they share a side, so we know that side length is the same. So then we can do what he was saying about the alternate interior.
so if we extend, just look at the parallel lines, right? Because what Leanne was saying was alternate interior. We have three options, probably more than that actually, of what we can look at for alternate interior. I think what Leanne is probably talking about is this, but we also actually could look at the angles created over here and the angle plural, angles created over here. So when we look at a quadrilateral or a parallelogram, come on, work with me. We have a lot of sets of angles that we can look at. Now this gets a little complicated in here, right? But we do actually have vertical angle sets then that we can look at. So if I move
We can get a lot of angles.
these two for a minute to look at what I think just Leanne was talking about. I don't know what color. So this angle, well, crap, that's the whole, I don't need that whole thing.
You just need the one that cut it off.
That
so it's
angle would be congruent to that angle.
So if we do this angle and that angle, okay.
So then we know.
And then that angle.
So then if we focus on the other two lines, like instead of the ones that are parallel, we like focus on the other two lines that are parallel, then we know that the other angle.
If we focus on the other two lines that are parallel.
Okay, so you could say this. Yeah.
If we focus on those on and then ignore the other set of parallel lines, then
You would also have
the other
more.
side.
Oh, we could call like this a transversal.
That's not. No, I was still thinking about the same one. So if
The same?
if we still use the same transversal but on the blue lines, then we have the other set
Yeah.
of angles.
Yeah.
The bigger angle.
Oh,
Yeah.
you're saying
It took forever.
Oh,
I thought it'd be a really simple thing to say, but no.
so from green to blue,
Yeah.
from green to blue.
There we go.
Oh, that's how we could prove those angles.
And
Then
then
the big one too.
we know the other angles are the same because the triangle angles are.
Because triangle angle sum theorem, these essentially just get roped into agreeing with everything that's already been going
They
on.
don't have over.
So then we know they are congruent because angle.
Similar.
So, if we were to write this out, like in a flowchart, not gonna make you flowcharts,
Oh.
but if we were to write this out, what would we start with?
Good.
Sammy, I'm
This
just gonna
is
jump around.
Off topic. It's still about flowcharts though.
Sure
I was
it
wondering
is.
if next year do we still work with flowcharts?
Yes.
I mean, depends on your teacher, really. You have to be able to write a proof.
Oh, well, that's simple.
Whether you use flowchart or two column is often up to you. Flowchart, you just put the reason in between. Right? So do you want to practice a flowchart?
I know how to do it. I just don't like it.
Let's do it.
Okay.
I think I
I mean,
want.
that's, you don't have to like them. Like, I'm okay with that. I don't like them either.
You get the thing
Well,
for
you
like
use a three-
triangle. ABC is congruent with thing, for example, not that, but like ABC is like triangle.
But we don't know that. We don't start with that.
I feel like
No,
we
you
figure it
do
out.
the
You do
three
like
bubbles and
Yeah,
then
you do
how
like
they
the three
relate to
bubbles.
the.
What would the top bubbles be?
the three.
In this one, it'd be the angle.
One at a time. Give me hands if we need. What do we start a proof with? Sammy?
The parts of the similarity. So this one would be angle, side angle.
That's not how we would start. Liang?
The statements, like this,
What statements?
like the angle on the side.
That's not how we start.
Make circles.
That's not how. Well, okay. If we were doing a flow, if we were doing a flow chart.
Well, you do the first.
Okay, so turns out we haven't done flowcharts since.
I know
Turns out you haven't done any proofs in a while.
I know how to make them.
Statement.
I just don't-
Reason.
Oh,
Right.
okay,
In a
well, that's
flow chart,
Yeah.
you just have the statement and they're like statement in a circle and then the reason, and then statement in the next circle and the reason. They just flow to each other. I like two columns better because it just lays out very systematically.
I thought you were talking about how we would start with the flow chart, like
Yeah.
making sure the
We always start with the given. Always. You have to define what we're working with. So our given here would be ABCD is a parallelogram. Right? So on your paper, you should have graph paper out. Why do we not have graph paper out?
I have graph paper, just not ABCD is a parallelogram.
And then kind of sub-givens. But we wouldn't say given here again.
No.
Wait a minute. Hold on. You wrote AD slash.
Where?
Wait, what's that?
Definition of parallelogram.
It's AD, and then those two lines make like AD is parallel.
Wait, AD slash BC.
No, parallel. Not slash slash. Parallel.
Okay, that's the
We're just not writing out the word. We have math symbols that we can use.
parallel to BC.
So definition of parallelogram because
Parallelogram is defined by a shape with two sets of parallel sides. We have defined the two sets of parallel sides.
so we know it's a parallelogram and we know those are
Parallel.
parallel because
Wait.
the
If it's already given that it's a parallelogram, why do we have to then say that the sides are parallel?
Because we're setting up what we're gonna use.
Okay.
So A, B, C, D, you would assume it goes in order, but it's like a little bit of redundancy just to protect us in a way.
Okay.
So then, I actually have to take this. I gotta try to schedule. Actually, I think this is my vet. See if you guys can decide what would come next. Statement, reason. We gotta work through the proof to get to the point where we can say that those triangles are congruent to each other. So we have to prove those congruent angles and all of that stuff. Right? Try that out. Try
so
it.
then do you want to start with like the transversal and we know it's the same for both because it's the
No, you're totally good. I have 5 kids in this class and they're all
yeah, so like DVC is equal to B. So let's
And,
I'm just assuming it can mess with the board.
Yeah.
So should I go ahead and label?
Oh, no, they don't label. It's hard to see because it's
Just say angle.
Yeah,
So we know.
We can say angle. Okay, can we
angle
label the angles?
DVC.
Okay, I'm gonna label the angles, okay?
No, David,
No.
it's angle DVC. It can't add in.
Oh, this is AB. Oh, sorry, this is zero.
Do you want to label the transversal?
The
The
transversal.
transversal. The transversal is DV.
Can we say angle?
Yeah.
I guess. Yeah.
Angle A, half of angle
say-
BDC is congruent to angle ABD because of alternate angles.
David, we want to start with the side because it's easier, and then we go into the angles.
So,
Okay.
Because-
side DB
It's,
is congruent to side DB
no, it's DB is congruent to BD.
because of reflexive property.
Yeah.
I think it was called that, right?
Yes, it is.
So reflexive property.
BD is congruent to DB. Reflexive.
Good morning, Phoenix. At the lunch break, if I could please see Savannah Parsons in the remote office. Savannah Parsons, please stop by the remote office at the lunch break. Thank you.
Wait, isn't that what we're like proving?
We're trying to. What are we trying to prove right now?
Like,
We're trying to prove that the triangles are freaking congruent to each other. And
no,
we're
isn't that like the reflexive property? Immediately just go have.
No,
See?
so we're trying to
Only one
prove that
side.
they're similar. So we proved the side, and now we need to prove
we
the
don't need to.
angles.
No,
I
we're
know,
trying to prove that they're congruent. Not
Yeah. So we already proved the
Let's get some
side.
angles.
Now we just say the angles, like I said,
Yes.
angle BDC.
Okay, angle DBC.
Angle DBC is congruent to angle
Wait, BDC is DB. No.
DBC is congruent to
BBC, BDA. BDA. Right? Okay, so DBC, that's congruent to blue, red, green. So that'd be
BDA.
BDA.
She said that like 5 times.
Yeah. And we know that
Alternate
because
and series.
yeah.
Alternate property or something. Okay, that's all we need. No, we need another angle.
Yeah, so get the blue.
So then we know that angle AB,
I already had a blue one.
D,
DBC is the.
we got the
blue
red
one.
ones. Now we're doing BD.
Wait, did we get the red or the blue?
We got the red one. We got the red one.
Yeah, so angle ABD is CD.
Wait, say that
No,
again.
CDB.
Same thing.
Say that
No,
again. Wait,
no,
say
it's
that
not.
again.
It's CD.
Wait, say that again.
Okay, so angle A, B, D, green, blue, red is congruent to angle C, D,
Thank you.
B.
And that is also alternate interior.
And then that's
Okay,
side
we're done.
angle.
And then we can say triangle A, G, A,
Yeah.
B.
So what was the next thing that you said?
We did the transversal is
Congruent
congruent
towards
on both of them because of the reflexive property.
It's
So
Wait. The transversal is congruent. The transversal is the line.
I was
the
thinking.
transversal.
So
the
line
transversal.
DB is congruent to BD. because
Line
of the
DB
reflex-
isn't congruent to anything.
It is congruent to BD.
Yeah, reflexive
So-
property.
Because
They
of
share the side.
Yeah, they share it.
because of the reflexive property.
It's angle side angle.
Right?
Reflexive is yourself.
Wait,
Because,
it's
reflexive, right? It's you are yourself. Just
And then you have the
angle.
angle. DBC is congruent to angle
is
BD.
it angle side
Why?
angle or is it angle side?
Reflexive. No.
Oh,
It's alternate interior.
Angle.
how does this have anything to do with alternate interior?
No, we're not saying that.
We're proving it's congruent. So.
Well,
trying to prove
proving
that
it's
congruent.
congruent.
Yeah,
so you
so
wanted
that's
to
So
fine.
that's one side is congruent. So
Okay.
now we only need two angles, and we found the two angles using the alternate interior thing.
So now that we know.
Angle DBC.
Whoa, what just happened?
Wait, it equals definition of parallelogram.
What is happening? AB is congruent to BC. What?
Not AB, sorry, that's AD.
Oh, because they're parallel, then they're the same.
Well, just because they're parallel doesn't mean that.
I know, but I said they're parallel and the same.
Because it's a parallelogram.
Okay.
Parallelogram not only has the parallel sides, but it also says that those pairs are also
So then we
congruent.
could
It have to be
Side,
congruent
side,
because
side.
then they would be.
So then we could say, once we have this reflexive, that those triangles are side congruent.
So we forgot one step, but we were close.
I mean, but we still got the answer.
Now, so there are two ways that you could take this. You could either use the transversal of parallel lines and use the parallel line rules, alternate interior, alternate exterior, whatever. Or, if we prove that the triangles are side congruent, we're done. Because that's what we were trying to prove. So, from defining the pieces of the parallelogram and adding a transversal that we can use just as congruent to itself, we can prove side.
Yes.
Or
We
you can
like
go the
the
angle
angles though.
Why
I just want to make sure you
so
think
far
about both of
away
them.
that Hudson's just like, now, children, what about this way?
Now, children?
If he said that.
I don't really say children.
Children.
Um,
3 times every day.
child.
Oh, I
So,
said child.
Kip.
I say children.
You say it a lot.
I say child, but not
Can you
children.
say it?
Kip takes that triangle from problem 1, right, and he does this with it. He reflects it across its top quote-unquote line. Right, so this side is congruent to that side. This side is congruent to that side. This angle is still congruent to that angle. This is now like one big angle. But this is still congruent to this, and this is now like one big angle. What sort of shape is this? Oh, Kip made a kite.
Kip made a kite.
Kip made a kite.
Kip made a
So,
Say that 5 times fast. Kip made a kite.
what is it that, trip on words. What does a kite have special about it? Why is it a kite?
Because it's two triangles. It's a triangle.
Okay, but if we get rid of this line and don't care about two triangles reflected, what's special about it? How's a kite different than a parallelogram?
It doesn't have.
Not parallel.
It's not parallel, that's obvious, but
It.
It has a parallel. Two sets of parallel lines, but they're not like across from each other. No, congruent.
Yeah.
we have adjacent congruent sides. So, in a kite, and if you can't remember this, just like pulling information out of your head, you might want to write it down. In a kite, we have to have two sets of congruent sides. However, they're adjacent to each other not opposite each other. What that also creates is two congruent angles
It's the opposite angles that are.
that are opposite of each other.
That's what I was trying to
What
say.
are those
It says on
angles
the
also
paper.
equal then?
These?
Yeah.
No.
Because they're.
Come on, dude. That's obtuse.
Oh.
That is acute. Now, they might have some kind of relationship. I'm not saying they don't, have a relationship. So Kip's kite, made up of two triangles. We've got some congruent sides, some congruent angles.
What are we trying to do in this? Is there a
Now we're
goal
thinking
or-
about D. Now we're thinking about D.
What?
So this line I crossed out, right? What is it?
Oh, it tells us that this bisects that
Bisects what?
angle that and angle that.
So if you on your sheet go down to the next one where it shows the
The angle.
front of the theorem graphic organizer, that front bottom, that is an angle bisector, right? The diagonal, even though here it's vertical, the diagonal, this, I'm not on pen anymore. I'm out of colors. This diagonal is the angle bisector. Now, there's another diagonal, right? If I am talking about just diagonal strictly, there's also that diagonal. Is that an angle bisector?
No, it's not. It's not. Like,
Wait.
Split it in half.
It's definitely not an angle bisector, right? This is not
But it
bisecting
makes
these angles.
right angle.
It does.
It looks like it makes a right angle.
So it's perpendicular.
it's perpendicular to the angle.
What else is special about the intersection of those two lines? And then I'll get you out of here. There's another bisector.
Oh, like totally, yeah. Oh, wait, wow. Oh, no, now it's KIT.
KIT.
How's KT relate to EI?
KT relates to EI. They're perpendicular, but.
Oh, split in half.
Yeah.
It bisects.
KT bisects EI.
It
Oh,
bisects from-
snap.
It's not.
KT bisects EI.
Yeah.
KT
It's
bisects
a one-way
EI.
relationship.
It sounds
All right.
like saying Katie. Like
EI. Oh, that's all we have for today.
EIO.
EI. Have a wonderful day, guys.